Hi, this is Mr. Schnitzius, and we're going to do Embedded Assessment 2 for after Activity 21. So just like all the embedded assessments, we recommend that you pause this video, work through the problems, and then unpause it, and we'll go over the answers together. Yoshio owns a farm that uses wind turbines to produce wind power. Wind power, also known as wind energy, uses the power of the wind to generate electrical or mechanical power. So number one says one of the wind turbines that Yoshio owns is shown in the figure below. He needs to know the height of the turbine. Yoshio is 5 feet 6 inches tall. If he stands 12 feet from the turbine, his line of sight forms a 90-degree angle with the top and bottom of the turbine. So the first thing that they want to know is what special segment is segment ZW? Well, since that is forming a right angle between the height of the turbine, xy, and point Z, that is the altitude. Segment ZW is an altitude of triangle XYZ. That's a perpendicular segment drawn from a vertex, in this case Z, to the opposite side. So point B, or question B, is saying write a similarity statement to show the relationship among triangle XYZ and the two triangles formed by drawing segment ZW. So far we've outlined triangle XZW. We know that that's a right triangle because segment ZW is an altitude. You learned earlier in this unit that the right triangle altitude theorem says when you have a right triangle and you draw an altitude inside the triangle, you form two more right triangles that are similar to each other. So we've also got this right triangle that we're outlining in red on the bottom. And you've got right triangle XYZ, the largest right triangle that we started with. So all three of these triangles are right triangles, and the right triangle altitude theorem says that they're all going to be similar to each other. The best way to write the similarity statement correctly is to draw the three triangles so that they're all facing the right direction. So this is going to be a little sketch. It's not going to be perfect. So we're going to put point X at the top. We're going to put point Y in the bottom right. We're going to put point Z as the vertex of the right angle. And we're going to name that triangle X, Y, Z. We also have the right triangle on the top that we outlined in purple to start with. So that's going to be this triangle here. So at the top we have point X. The vertex on the other end of the hypotenuse is point Z. The vertex of the right angle is point W. So since for the blue triangle we did the point at the top and then the other end of the hypotenuse and then the right angle, triangle XYZ. For the purple triangle, we're going to do triangle XZW. Then we've got the small red triangle. So we're going to label these vertices. Z is going to be at the top if we draw it facing the same way as the other triangles. Point Y is going to be the other end of the hypotenuse. Point W is going to be the vertex of the right angle. So if we do the point on the top first, that'll be point Z. The other end of the hypotenuse will be point Y, and the vertex of the right angle will be point W. So in part C, when it's asking us to find the height of the wind turbine, that means all of segments XY. What is the length of segment XY? Well, we know that that's made up of two segments. It's made up of segment XW and it's made up of segment WY. This problem shouldn't be too hard because we already know that segment WI measures 5.5 feet. So all we need to do is find the length of segment XW. Well, we've got two sides that we know in this bottom triangle. And we've got, for the triangle that we highlighted in purple earlier, we've got the length of the base that we know. We need to know the length of the height. So to make it look like we saw it on the last page, let's redraw the smallest triangle on the bottom so that it's facing the same way as the purple triangle. So we've got a relationship between the base of the triangle and the height of the triangle. So in triangle XZW, the length of the base is 12 feet. The length of the height is the side length that we're looking for, that's segment XW. In the triangle on the bottom, triangle ZYW, the length of the base is 5.5 feet. The length of the height is 12 feet. So now we can cross multiply, and we're going to get 5.5 times the length of segment XW is equal to 12 feet times 12 feet. Well, on the right-hand side of the equation, we're going to get 144. To get the length of segment XW by itself, we need to divide both sides by 5.5. So that's going to tell us that the length of segment XW is 26.2 feet. And now, in order to find the final answer, we're going to add that 26.2 feet plus the 5.5 feet representing Yoshio's height, and that's going to give us a final answer of 31.7 feet. So in number 2, we have another picture. We've got some different right triangles that we're going to use to solve this problem. Part A is asking us to find the length of segment AB. So we're going to use right triangle ABC, and they tell us that segment AC is 15 feet. We know that in any triangle, the sum of the interior angle measures has to be 180 degrees. We've got a right angle that's already used 90 of those degrees, so these two acute angles have to be complementary. So 60 degrees plus how much is 90 degrees? That would be 30 degrees. So now, since this is a 30, 60, 90 triangle, we can label our sides x times the square root of 3, and 2x. And if we want to know what the length across from the 30-degree angle is, we just need to solve this equation for x. So that's x times the square root of 3 equals 15 feet. To get x by itself, we can divide both sides by the square root of 3. So that's going to give us x equals 15 over the square root of 3. But we do not want a square root of 3 in the denominator, so we're going to multiply the denominator and the numerator by the square root of 3. So that's going to give us 15 times the square root of 3 over 3. 15 over 3 reduces to 5, so that's 5 times the square root of 3 feet. But that's not the side that we're looking for. That's actually the length of segment BC. In a 30, 60, 90 triangle, if you know the length of the short leg, you just need to double that to get the length of the hypotenuse. So that's going to be 10 times the square root of 3 feet. And that's our answer for the length of segment AB. The part B is going to ask us to find the length of segment AD. That's the hypotenuse of this right triangle ACD. So this is length of 15 feet right here. This time we're going to have a 45, 45, 90 triangle because these two acute angles have to have their measures add to 90 degrees. So in a 45, 45, 90 triangle, we can label our side lengths x, x, and x times the square root of 2 this time. So if the value of x is 15 feet, and they want to know the length of segment AD, we can just substitute 15 for x, multiply that by the square root of 2, and that's going to give us our answer, 15 times the square root of 2 feet. Part C and D we're going to do together. This time we know the same length of segment AC is 15 feet. This is another 30 degree, 60 degree, 90 degree triangle, and we can label our side lengths x, x times the square root of 3, and 2x. Well, your 30, 60, 90 triangles are very easy if you know the length of the short leg, especially if that length is a whole number. So the length of segment AE is going to be 2 times x, whatever x is. Well, x is 15, so we can simply substitute that. 2 times 15 feet is going to be 30 feet. That's pretty easy for the answer for part C. And it's going to be the same type of thing for part D. What is the height of the turbine from E to C? Well, if x is 15 feet, we can just substitute that in for x. So that's going to give us 15 times the square root of 3 feet. The last problem here is asking us to use the converse of the Pythagorean theorem to prove that triangle AEC is a right triangle. So we have to do a squared plus b squared equals c squared. C has to be the hypotenuse, so that's going to be 30 feet. We'll let A be 15 times the square root of 3 and B be 15 feet. So if we plug that into the Pythagorean theorem equation, that's 15 times the square root of 3 squared plus 15 squared equals 30 squared. Now it's really, really important that you put those side lengths inside parentheses. Just to get into a good habit for when you're squaring negative numbers. But for this one, it's especially important because we don't want to just square 15. We don't want to just square the square root of 3. We want to square both. So that's really 15 squared times the square root of 3 squared. The square root of 3 squared is 3. We already saw that 15 squared is 225. Oop. So 3 times 225 is 675. Plus 225, that actually does equal 900. So since we have a squared plus b squared equal to the same thing as c squared, that proves that this right triangle is a right triangle. Thank you so much for working through this with us. Hopefully this helped you and you can use this to study for your Unit 3 quiz.